chapter 7. We're going to go over trigonometric functions in this chapter. So, of course, it's split in between two sections, which most of these chapters are. The first section that we're going to go over, blow it up for you guys a little bit. We're going to understand something when it comes to those trigonometric ratios in a right triangle. And we started playing around a little bit with trig this year. And looking at those three functions. You guys know what those three functions are? Sine. Yep, those are the three we're going to be looking at, right? We're going to kind of look at some multiple different types of representations for those. Today we're going to kind of look a little bit like at a unit circle, maybe a triangle, something along those kind of lines to work on those, and then figuring out some other little goodies when it comes to those trig functions. And then in the second section, we're just going to take all that information that we used in the first section, and then apply it in the second section by kind of making some graphs, moving those graphs around, and having fun with it. Sound like a plan? All right. So the first section, 711, has to do with the cyclic relationships. And what does that all mean? So, excuse me. So if something is cyclic, it means it goes around in a cycle. So it's kind of, we call, like it's going to go through a cycle, and then it's going to go through another cycle, and each one of those cycles are like the same thing. So kind of like class sometimes, right? We come in, I take attendance, we take notes, you do assignments, you leave, you come in. So a lot of times these cycles happen in nature. So if you live by the ocean, an example would be the tide. Because what does the tide do in the ocean? It goes high tide, low tide, high tide, low tide, right? So the water goes out, the water comes in, the water goes out, the water comes in, right? So it goes in that cycle. So it slowly goes out, and then it slowly comes back in. What about the moon phases? So, and I don't know the proper terminology for this. So I know we start off with the new moon, which is where it looks like there is no moon, or you can just barely see it. It kind of looks all dark. And then you get that little crescent moon, and then that crescent keeps getting bigger. And I know each one of these cycles has a scientific name, right? So you got like that little crescent, and then it gets to like where it's half moon, but we don't call it half moon. I don't know. And then it gets to where it's almost the whole entire moon. It's like 3/4 of a moon, and it just kind of keeps going, right? And then we get the full moon, which is the big bright, full moon when the werewolves come out and eat us. And then it goes right back, and then it's like you go from that full moon, then you lose that sliver, then you lose up to half, and then up to 3/4, and then it kind of, quote unquote, kind of like goes away, right? And then they're back to the new moon. So you go from new moon to full moon to new moon to full moon. And kind of like the same thing with like planet movement, right? Or their orbit. Hopefully, right, they stay in the same orbit so nothing collides, right, and they kind of go around. Or even us, if you think of like our planet movement, it kind of gives us these 4 seasons, right? So right now you got spring, right? So we go from spring to summer. You guys call it fall or autumn? Fall. And then to winter, right? Oops. And then it comes right back, whoa. Then it comes right back to spring, right? So it goes through that cycle over and over again, year after year. Clocks. If you think of the hands on a clock, right? What's it do? It starts at 12 and it goes all the way around until it gets to 12, and then it keeps going around and around and around. Right? Kind of like the wheels on the bus go. Not gonna happen today, is it? No. All right, that's fine. That's fine. All right. So we got on understanding cycles, like what a cycle is, and then what they say, like if you think of like the tide is kind of the easiest one because it's just got the 2. So on the tide, the tide goes out and the tide comes in. like that completes one full cycle. So a lot of times we call that a period. So every time it goes through that full cycle, it's a period. So out and in would be period 1, like out, in would be 2 periods, right? All right. Sorry. I choked on my apple at lunch. Like it was a really juicy apple. Have you ever like bitten into like a juicy apple and you like go to suck, because you don't want the juice to run out of your mouth, so like you can't like suck it. And it went down like my windpipe, so I was in here like choking. So I still got that tickle in my throat. So I know. All right. So we're going to talk about 3 things, and then we're going to try and put these guys all together. So we talk a lot about quadrants, and our quadrants are in like our little coordinate plane. So if we draw like our y-axes and our x-axes, and some really bad arrows. And then each one of our quadrants has a special little name. So kind of like our upper right quadrant, this is known as quadrant 1. Yep. If you go to the left, that's quadrant 2. Bottom left is 3. And bottom right is 4, right? So this comes in handy because when it comes to our quadrants, and our quadrants, it's graphing all those XY points. And we can even talk about our values for like X's and Y's, like they're positive and negative. So when I'm in like this first quadrant, my X values are always going to be positive or negative? Positive, yeah. What about my Y values? Positive, right? And if I'm in quadrant 2, negative, positive. Yep, good job. Yep. And if I'm in quadrant 3, negative, negative. And in quadrant 4, positive, negative, right? So that's going to help us out when it comes to looking at these trig functions. The other thing we're going to talk about is the unit circle. So this is kind of a little new to us. Okay. So when it comes to a unit circle is always going to be a circle that has a radius of 1. Or the radius equals 1. And we like that 1. It gives us a nice little standard. So, and we know that not all circles have a radius of 1, but if you ever see anything calling a circle a unit circle, it will always have a radius of 1. So if we think back to our equation of a circle, x squared plus y squared equals r squared. And what's our radius? 1, right? So our unit circle is going to be x squared plus y squared equals 1. So if you ever see x squared plus y squared equals 1, we always know that it is a unit circle. Yep. Oh, and then the last thing is our trig functions. And you guys already told me these ones, right? There's more than 3, but just for right now, we're going to look at the 3. So we're going to look at sine. And sometimes we like to abbreviate that as SIN. It's not a sin. It is sine. Right. And then we have our cosine. We like to abbreviate that with COS. And it's not cos, it's cosine. Right. And then we got tangent, which we like to abbreviate with TAN, right, for tangent. It's not a tan. It's not getting some sun on it. It's just a tangent, right? So when it comes to looking at these trig functions, we're going to take all 3 of these and kind of start combining them together to talk about some problems that we want to look at. Sound good? Actually, I think I can just blow it up. We're going to do this. All right. So we're going to make a circle, And then with our coordinate plane, like going, our XY axes going right through the middle of it. I luck out a little bit because I get a little circle drawer on my little app because if it wasn't for this, I don't think I could draw a very good circle. So we're gonna start with a nice little circle. See that? Bam! And then through our circle, we're gonna have our Y-axis and our X-axis. I look pretty good, don't I? So when it comes to our circle, we need to figure out how we make a circle. So if we think of our quadrants are those X and Y's and those points, right? And this X and this Y have to do with our coordinates that are on our coordinate plane. So when it comes to a circle, guess what a circle is made up of? Points, right? And then these points just got really close together, and when they got really close together, guess what it formed? Circle. It formed that circle. So our circle is just a whole bunch of points, no different than a line, right? Just in a different arrangement. They don't have the same slope, right, like a line does. So what we want to do is we want to be able to go through our circle, and we want to be able to figure out the points that are on our circle. And the trig part of it is we want to figure out the angles that are in our circle. Because if we go all the way around a circle, how many degrees is it? 360, right? So those degrees is 360, or that angle measurement is 360 degrees. So we're taking those angles and we're finding those points that are on the circle, or the other way around, right? We're finding points on the circle and we're figuring out where around that 360 it actually happens at. So we can label some of our fancy points with points and degrees. So I'm going to blow this up a little bit, right? So we know that if we start here and we go all the way around the circle, we went how many degrees?
360.
360, right? So we can label this at 360 degrees. Oops. And if we didn't start at all before we started, this would also be our 0 degrees. It would be our starting point. So when it comes to our angles, we always start at the center of the circle, or that origin of our X and Y coordinate planes. And we always say, like, this is the initial side. So we always start going down the X-axis. And then the other part of the circle would be like the terminal side. So then this would be like the initial, and then I go here, right? And then that's how I created that angle. So then if going all the way around is 360 degrees, how far would it be from here to here? 180 degrees. Yep. How far do you think it would be from here to here? 90 degrees. Yep. And if you were to draw out that angle, right, here's that initial side. Here's that terminal side. What did you make? You made a 90-degree angle, right? And then how far would it be from here all the way to here? 270? Right? And then we can sit there and figure out some more of the angles, and we'll work on that in a second. So remember, there's that relationship between angles and actual points that are on the circle. So this is a unit circle, so what's our radius? That's going to be 1, right? So let's see if we can figure out what this point, oops, I'm going to even color it. This point right here is on our unit circle. So we got X, Y coordinates, right? So if I start at the origin, how far to the right do I go? 1. How far up or down do I go? 0. So that would be the point 1, 0. Right? Let's see if we can figure out this point. Okay. So if I start at the origin, how far to the left did I go? Negative 1. How far up or down did I go?
0.
0. So this would be the point negative 1, 0. Right? Oh boy. All right, where were we? All right, so let's see if we can figure out a couple more points. So let's see if we can figure out this guy up here at that 90-degree angle.
0, 1.
Yeah, 0, 1. I went left and right how far? 0, and I went up 1. What about this one down here at 270? 0, -1. You guys are rocking it out. All right, now I got one for you. What about this point right here? So this is where a little trig is going to come into handy. So what we would do is we would actually measure that angle from that initial side to here. And so I know that that angle, because I'm going to make it up because I'm the teacher, I'm going to say that that angle is 45 degrees, right? So there's a relationship between what that angle measurement is and where it is going around the circle. So then I can figure out what that point is. And we know that that point is an XY coordinate, right? And this is where our sines and our cosines come in handy. When we're looking at X values, we're always looking or talking about cosine. And when we're looking or talking about Y, guess what value we're looking at? The sines, right? So X always correlates to cosine and Y always corresponds to sine. And a lot of times, when I'm first starting off with these, think of it alphabetically. Which comes first alphabetically? Yeah, X, right? And then which, oh no, you're fine. Between X and Y, X comes first alphabetically. What comes first between sine and cosine?
C.
Cosine, right? C, so yeah, so put those together alphabetically. Sometimes that's how I kind of remember it when I'm learning these guys. All right? So if I want to figure out my X coordinate, it is going to be, oh my goodness. I like blew this up and I feel like I'm writing so big now. My X is going to be the cosine of my angle, which was 45 degrees. And my Y value is going to be the sine of 45 degrees. So then we're going to hop on over to our calculator or to Desmos. And then this is just one little piece you got to be careful on when it comes to our calculators that we're using. We're talking about degrees right now. And here shortly we're going to talk about these things called radians. But right now we're talking about degrees. So most likely if you got your personal calculator, most likely hopefully it's still in degree mode. If you're on Desmos, there's a little toggle. So if I click on that toggle, what do you see? How you see that it's rad? Because it's awesome, right? It's just telling you that that's in that radical mode. If you click that toggle again and it says degree, then that's how you know you're in degree mode. So since we're talking about degrees, we got to be in degree mode, right? So to figure out our X value, it was what, the cosine of what degree? 45, right? And then we know, I'm just going to round it to 0.71, right? And then to figure out my Y value, what was it? Sine of 45. And I get the same value. That's kind of cute, right? So we're going to say that our X value was 0.71 and our Y value was 0.71. "60 degrees, let's say, would have been right here, right? You guys don't have to write it, right? So I'm going to get rid of my 45 degrees. So from here to here is 60 degrees. And do we know what that point is on the circle? No. So what are we going to do? The cosine of?
60.
Yep, the sine of?
60.
60, right? We're going to plug that into our fancy-dancy little Desmos. So the cosine of 60 is going to be half. And then the sine of 60 is going to be 0.87. Okay. Fill those in for you guys. So here in a little while, we're going to learn some crazy like little values, like where these all come from. If you go back to when we had that 45, you guys don't have to write this down. You know when we went back to that 45 degree? And we knew this was 45 degrees. I can take from my point and I can drop that straight down and make a perpendicular with my axes. And what's my other little angle going to be up here?
45.
It's going to be 45, right? And what do we know about 45, 90-degree triangles when it comes to their side length?
They're all the same.
It's the same, right? So when it comes to that x value, how far did I go across? 0.71. So how far did I have to go up? 0.71, right? Because those are the same. So the same thing happened on the 60-degree triangle, right? Where that was 60 degrees. So then I knew this top angle up here was 30 degrees. So remember in geometry when you learned about 30, 60, 90s? That's exactly where those values are coming from, right? And then we can learn another one over here that's 30 degrees. So then like the same thing happens. That's 30 degrees. This is 60 degrees. You got your 90 degrees. And now you're into that 30, 60, 90 triangle again. You were hoping to get rid of those special right triangles and never have to deal with them again, weren't you? Yeah. And then really once we sit there and figure out a lot of our values that are in this first quadrant, we can figure out all of the values going all the way around the circle because we know what coordinates they are. And it's like, if I take this 45 degrees and I were to flip it straight across, the only thing that changes is my x becomes negative, right? So that would be negative 0.75, 0.71, positive 0.71. If I dropped it down to the third quadrant, both of those have to be negative, right? If I shoot it across to over here to the fourth quadrant, my x is going to be positive 0.71 and my y is then going to become negative.